Steps that we're going to take to solve radical equations. We'll start with step 1. We are going to isolate the radical on one side if possible. So we'll isolate the radical on one side if that's possible. Then we are going to, in step 2, raise both sides of the equation, not terms, but sides of the equation. So both sides, I'm going to capitalize that, to the power of the index. Okay, this may mean that FOIL is involved. Not always, but sometimes you may need to FOIL. Step 3, we will rearrange and solve for the variable. And then step 4 is crucial. So crucial that I'm going to write this in red. This is a crucial step. We need to check for extraneous solutions. There are a couple ways that we can do this. Usually plugging it back in is the easiest, or what I found to be maybe the most common way to solve and check for extraneous solutions. So let's get started. We've got number 7. We've got the square root of 3x plus 1 equals 7. Now, the radical is the square root of 3x. That's what we want to isolate. So we want to get that on a side all by itself. So in order to do that, we're going to subtract 1 from both sides. So I have the square root of 3x equals 6 because I subtracted 1 from both sides. Now we're at step 2, and it says raise both sides to the power of the index. Well, this is a square root, so we're going to raise both sides to the second power. So we undo a square root by squaring. The square root of 3x times itself is just 3x. I'm going to go back to green here. That's just a 3x. 6 squared is 36. I divide both sides by 3, and I get x equals 12. Now I need to check for extraneous solutions. So I need to check to make sure that 12 is going to work. So when I take 12 and I put it back into the radical, I need to make sure that if I have an even index, that I have a positive radicand, or at the very least, a 0. I cannot have any negative numbers. Well, good luck is happening here because we've got 3 times 12 is 36, and the square root of 36 is most definitely allowed. Therefore, x equals 12 is not an extraneous solution, it is an actual solution. It works, so I'm boxing it. Number 8, we've got the square root of 5a minus 1, and that's equal to 6. I am going to highlight my radical, and I'm going to try and get it on a side all by itself. And when I highlight that, I realize it already is all by itself. Therefore, I can go straight to step 2, and step 2 says, I liked using that green. Step 2 says that you raise each side to the index of the radical. Well, that index is a 2, so I'm going to square both sides because a square will undo a square root and vice versa. Well, the square root of 5a minus 1 squared is just 5a minus 1. And 6 squared is 36. We're going to add 1 to both sides. And we get 5a equals 37. I divide both sides by 5, and I get a equals 37 over 5. Well, 37 over 5 is about 7 2/5. So a little bit more than 7. So when I take this and I plug it back in, because I'm checking for my answers. So when I take this and I plug it back in, it's easier for me to plug in a number that's a little bit bigger than 7, because then I can guesstimate. 5 times 7 is 35. So 5 times a little bit bigger than 7 would be a little bit bigger than 35. Minus 1 is still positive. That's going to work. Therefore, a equals 37 over 5 works. Now, if I want to be exact, I'm going to plug it back in, and I'm going to show you that sometimes it's not as even with a fraction, it's really not that bad. 5 times 37 over 5 minus 1. The 5's cancel, and I get 37 minus 1, which is the square root of 36. And then remember that equaled 6, and that's a true statement. Therefore, it works. Okay, you try number 9, press pause, and then when you come back, I'm going to go right to the answer, and then I may go back and quickly show my work, but I want you to be able to check your answer, and if you've got your answer, you can move on to the next problem. Okay, number 9 says the square root of x minus 2 minus 1 equals 9. Welcome back. I got for an answer x equals 102. And when I plugged 102 back in, 102 minus 2 was 100. The square root of 100 was definitely allowed. In fact, it's 10. 10 minus 1 is 9. It created a true statement. It's an answer. Now, if you're wondering how I got that, I said the square root of x minus 2 equals 10 because I added 1 to both sides. Then I squared both sides to undo the square root. I get x minus 2 equals 100. I added 2, and I got x equals 102. Okay, number 10, number 11, 12, those have different indexes. So, but the same process works. I'm going to isolate this radical. It's already isolated. So I'm going to write the cubed root of x plus 5 equals 4. And I'm going to raise both sides, this time to the 3rd power. That's because I have a cubed root, and cubing undoes the cubed root, which is going to leave us with just x plus 5. But then on the right, I've got 4 cubed, which is 64. I subtract 5 from both sides. I get x equals 59. And guess what? This is a cubed root. It's an odd index. Therefore, any real number is going to work. X equals 59 is a real number, so I don't have to check it. And that happens. No need to check with an odd index. So remember, when you've got that odd index, you're allowed to have any real number inside. When you have an even index, you can only have a number that is non-negative. Okay, number 11. Now that we did number 10, give number 11 and number 12 a try and see if you've got it. And then come back and I'll reveal both answers. Okay, welcome back. For number 11, the answer is n equals 19. And for number 12, the answer is z equals 64. I'll quickly show you my work so that you can check to see what happened. We've got the fourth root of n minus 3 all by itself already. We're going to raise both sides to the fourth power. That gives us n minus 3 equals 16. We add 3 to both sides, and that's how we got n equals 19. For number 12, we said the cubed root of 2z minus 3 equals 5. We cube both sides. We got 2z minus 3 equals 125. I add 3 to both sides. 2z equals 128. Divide by 2, and z equals 64. Now, the one on the left, number 11, we need to check to make sure we don't have a non-positive, because the radical can't be negative, so we need a non-negative number. So I need to make sure that when I put a 19 in, I'm getting a non-negative number, non-negative. So 19 minus 3 is not negative. Yay. As long as we don't have a negative, that's going to work. Now 64, do we even need to check it? The answer to that would be no, because it's an odd index. Now in the next video, you can see that our problems are going to get just a little bit more involved, and that's where we might have to use maybe a little bit of FOIL, and perhaps some factoring might be involved. And we'll do that in the next video.